Let us see this small topic, maybe that was keep in the list. The drift in transducer or measurement system, right? What is the meaning of drift? In order to get an idea about this, let us take the same diagram. Input versus output curve of a transducer or measurement system. Suppose the ideal curve is like this, and the actual curve is looking something like this. Ideal or initial, I can say. Initial curve. And this is curve now. Right? So, what is this you are observing in this curve? You see, in this particular curve, when input is increasing, output is also accordingly linearly increasing. But in this curve, which is present now, or showing by our measurement system or transducer, is it is actually drifted, right? By this much value, right? Are you able to observe that? Drifted by this much value. So this type of drift is called as zero drift. This type of drift is called as zero drift. The meaning of this is, you see in some of the meter, even though when there is no input applied, when input is zero, you see there is certain output present in the system. Have you observed this ever anywhere? In your bike, the dial, you see the speedometer dial. Okay, suppose this is the zero mark, and this is the indicator. Sometimes mark or point to a value which is pointing below zero, or sometimes pointing above zero. Have you observed this?
No, sir, but I have seen in voltmeter. Sorry, multimeter.
Yeah. Speedometer. Yeah, that's great. You have seen in multimeter or voltmeter. In voltmeter also, such type of drift can be seen, right? So this is called as zero drift. There is another drift called as span drift. In case of span drift, the thing which happens is, suppose this is our initial curve. That here, in case of span drift, the slope of the curve may get varied. This is input, this is output. What is this you are observing in this case? You see the slope of curve is getting changed, right? Initially the slope is this. What do you mean by slope?
y2 minus y1 by x2 minus x.
Yeah, great. In this particular case, can I write like this? Delta output divided by delta input.
Yes, sir.
Will that be okay? Delta output by delta input. This is slope. Suppose this is slope of initial curve, marking as 1. So this is looking to be this much, and slope 2 will be delta output 2 divided by delta input 2. Suppose this is number 1 and this is number 2. And in this case, we can say that slope 1 is not equal to slope 2. Hope it is clear to everybody.
Yes,
Yes.
yes.
So I can give the name to this as span drift. Okay, no doubt, not a point about this. Can I read?
Yes, sir.
Yeah, a change in an instrument reading, a change in an instrument reading or set point value or set point value over the extended period is called as drift. Is called as drift. See, sometimes we use the word instrument also, right?
Sir, once again, can you repeat?
Yeah, yeah, definitely. I will repeat. A change in in an instrument, in bracket you can write MS, that is measurement system. A change in an instrument's reading, in bracket you can write MS, that stands for measurement reading, close bracket, or set point value over the extended period over the extended period is called as drift. Is called as drift. Next, there are two types of drift. There are two types of drift. First one, zero drift. Second one, span drift. You can take the sketch. Can I move further?
Yes, sir.
Okay. Next, I will take up this reliability. What is the English definition of reliability term? Synonym of reliability?
Depending.
Yeah. How much we can depend on the instrument, right? So this is looking to be a difficult parameter, and it's directly nobody can measure this parameter. Direct measurement is not possible, right? Direct measurement of reliability is not possible. So what we will do is we go for some other methods of extracting this particular parameter. This can be called as feature extraction, right? So there are three ways in which we can extract this parameter. First is called as observer reliability. Second is called as test reliability. There are many methods. I am listing a few. And third can be parallel form of reliability. Parallel form of reliability. We will see each in detail in brief. Okay. In case of observer reliability, what we will do is we ask different observer, okay, to give comment on the reading coming out of an instrument, right? So that is called as observer reliability.
Sir, to give the comment.
Yeah, I will give definition. I will give definition. What we will do is we ask different user to give comment on the performance of the instrument. Like suppose I wanted to know about a particular person. Okay, suppose you take the case of HR. Okay, there are many ways of drilling the candidate to recruit for a particular post. One is directly asking question on one, right? And then one another way is seeing your accounts. One another way is asking about yourself from the institution where you study. One another way is cross confirming your cats from the university you study, right? So this can be called as observer reliability. Hope it is getting clear to you people.
Yes, sir.
Exactly in similar way. Okay, exactly in similar way. So a particular instrument under test or under observation or under reliability calculation, it will be asked to check by different experts or different observers, and their opinions are noted, and that can be added in observer reliability. Hope it is clear to everybody.
Yes, sir.
Yeah. Now next come to test reliability. So input taken from the human in this case. In case of test reliability, the consistency of measurement is evaluated over time. Is evaluated, right? Over certain time. That can be used in order to comment on test reliability. In case of parallel form of reliability, What usually happens is same instruments, same design of instruments are actually connected in parallel, right? Connected in parallel. And to these, same excitations are applied. Same inputs or excitations are applied. And their outputs are calculated. Their outputs are calculated. So depending upon how much the output differs, the reliability varies. Output 1 is compared with output 2, okay, and reliability is decided. Hope it is clear to everybody. Yes, no.
Yes, sir.
Yeah, take a few points about reliability. Reliability of an instrument is actually the measure of consistency of the instrument. Reliability of an instrument is actually the measure of consistency of the instrument.
Sir, is actually the measure of.
Consistency of the instrument. Consistency of the instrument. Okay? Can I proceed?
Yes, sir.
Yeah. Next point you can write, which is there on the board. Direct measurement of reliability is, instead of writing not possible, you can write very difficult. Direct measurement of reliability is, instead of not possible, you write very difficult. Very difficult. Direct measurement of reliability is very difficult. However, however, there are many indirect methods. There are many indirect methods which facilitate to estimate, which facilitate to estimate. Instead of find, we can call estimate, which facilitate to estimate reliability. Which facilitate to estimate reliability. Okay. First one, write down observer reliability. Second one, test reliability. And then third, you can write parallel form of reliability. Under observer reliability, write down it is the degree to which different observer give this reliability is the degree to which this reliability is the degree to which different observers give if different observer give consistent answers. Different observers give consistent answers. No, write about test reliability. Test reliability. So for that you can write this thing. It is the consistency, consistency. It is the consistency of measurement which is evaluated over a finite time. It is the consistency of measurement which is evaluated over a finite time. Over. Can I proceed?
Yes, sir.
Yes, sir.
Right. Third one, parallel form of reliability. Parallel form of reliability. The reliability of two tests. The reliability of two tests conducted in same way. The reliability of two tests conducted in same way from the same content, in same way from the same content.
Sir, can you start?
The reliability of two tests conducted in same way from the same content, from the same content. Is it okay? Can we move further?
Yes, sir.
Yes, sir.
Sir, in parallel form of reliability, means it is accurate, sir.
Can you repeat your question? Parallel form of reliability?
The results will be accurate, sir. The reliability result.
Actually, these are the different ways of picking the reliability information. This is performance parameters. So you mean to say that which method is best among these three?
No, sir. As we are performing an experiment with the same steps and the same what we'll say material, then the difference between them, the values will be zero, no, sir.
Yeah,
Then
yeah,
accuracy.
if that is the case, that is better with reliability.
Okay, sir.
That is what we are expecting. No? That is what we are expecting. Actually, this parameter, it's like a rating kind of thing over here. Okay, there is no unit of reliability. Nobody can give unit to reliability. Only uh, 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 how much observer will give point to the instrument, like 5 out of 4.5. Huh? 4 in this case, 4 out of 5. In this case, suppose 4.8% out of 5. Like that, some numbers can be given. Okay, in case of reliability. There is no unit of reliability. Hope it is clear to everybody.
Yes, sir.
Okay, next parameter is repeatability. Okay, this parameter is actually uh, slightly near to accuracy. Just definition I will pick. Repeatability. is the variation in measurement obtained when one person measures the same unit with same measuring equipment. Is this clear?
Yes, sir.
Sir, once can you show the definition?
Definitely. The meaning of this is, suppose we have a voltmeter, okay, and we are applying to this voltage, say 20 volts, and one person is asked to observe this thing. In iteration 1, he is observing 20.1. In iteration 2, it is observed to be 20. In iteration 3, it is observed to be 19.9. The variation in the reading, okay, is termed as repeatability. Same measuring, same, when one person measures the same unit with same measuring equipment. The intention of the same unit is nothing but same value of input. Hope it is clear to everybody.
Sir, the setup will
Yes.
be same, sir.
Yeah, setup depends. What are the parameters we are enforcing into the what are the that is called as actually constraints. That depends upon the scenario. Setup in the sense the environment can be same, the temperature can be kept very. So all depends upon the constraints.
No, sir, I am asking about the circuit. The circuit will be the same.
No, no. See, circuit will be absolutely same. See, understand here the scenario. I'm considering a case of voltmeter. According to this definition, if input is same, okay, and it is observed multiple times, and instrument is also same. Are you getting the point?
Yes, sir.
Voltmeter is same, input is also same, and observe the reading at different instants. I can call it to be iterations, different iterations. Like you are asked to take the reading many times. Yeah, see, your teacher is asking you to take 10 times reading from same instrument with same input from the voltmeter. Okay, in that case, the intention of the teacher is to let you to do the calculation of repeater. Hope it is clear.
Yes, sir.
Let us see the last term. Maintainability. Probability of performing a successful repair action within a given time. So this is actually statistical parameter. Statistical parameter. So in order to calculate this thing, we need to have a set of data, history of data, previously taken data, old data should be available. In that, one column can be serial number, one column can be input, and one column can be corresponding output. Okay, 1, 2, so on up to n, x1, x2, so on up to xn, y1, y2, so on up to yn. This is available. This is available. So in case of maintainability, so what we will do is we'll try to actually calculate the probability of, okay, probability of getting the same output uh, when we try to measure at different times. So probability of output is equal to success is how much? So if that is 50%, so we can see that probability of not happening is also 50%. So maintainability parameter is actually calculated from the probability of successful performing a successful repair action within a given time. See this particular definition, maybe you are thinking that repair means it give good performance, don't get spoiled in less amount of time. The intention is not, maybe that one, but we think from the point of view of data. If suppose this is the correct data, when we try to measure, how much we will be getting the same values. For x1, instrument should be giving y1. For x2, instrument should be giving y2. So how much this is possible? Is it possible that we will get this thing 50% success with 50% success rate, or we will get this with 60% success rate? All depends upon this particular parameter, which is called as maintainability. Is it clear to everybody?
Yes, sir.
Yes, sir.
So this is all about our static characteristics of measurement system. In from tomorrow's class, like it may take, I think, 3 or 4 classes for me to complete the dynamic characteristics of measurement system. So before closing today's session, what I will do is I will just review what are the things I am going to discuss in next 3 classes. Okay.
Sir, maintainability by its name only can be defined as how successfully a machine is running, right?
Yes.
Mm.
How much we
Sir,
can actually rely on the see the data which is coming from the instrument is having how much probability of successful answers.
okay,
I'm
sir.
I'm giving a worst possible answer over here. Usually, if 50% is giving by the instrument, cannot be actually accepted. Must give 95% of success. Maintainability should be 95%. That is probability of giving correct answer should be 95%. And wrong answer plus or minus 5%. Hope it is clear to everybody.
Sir, if this is the scene, then um, machine should be maintenance.
Perfectly designed.
Yes,
Perfectly.
designed and also maintained it by time to
Yeah,
time.
environment. See, every design gets spoiled when it is not maintained in correct environment. There are many other things which technically people give, like giving proper oiling, like cleaning. So many things are there. Maintaining temperature, okay, and maintaining the environment to be chemical free. Like that, there are so many parameters which the designer specified. If that is maintained, then whatever maintainability even by the designer can be seen from the performance of instrument. So can I go for to next thing?
Yes, sir. Yes.
So in this, I have discussed the content of dynamic characteristics. Instead of directly going into discussing the dynamic characteristics, because this is a wide discussion, so you will find discussion of dynamic characteristics in control system subject, in process control subject, right? So in this particular subject, what we will do is we start from the scratch. So there is actually connection to control system subject that we will see in detail, maybe next semester. Maybe it is there in fifth semester, I guess so. Control system subject. There is one subject called as process control. In that also you will see the discussion on dynamic characteristics calculation. So under transducer engineering, under unit 1, we are not directly going into discussion on dynamic characteristics. Instead, what going to do is we start from the scratch and discuss the modeling of measurement system. Okay. After that, what we will see is how can we how can we define the orders of the how can we give tag to the measurement system, like it belong to zero order, it belong to first order, it belong to second order. What is the significance of order? What, first of all we will see what is this order, okay, then we will see what is the significance of order, and then we will see what are the pits and falls of having smaller order and higher order. Okay. Okay, after seeing a modeling of measurement system or transducer, we will go to the next topic, and that is nothing but testing of uh, only first order measurement system model. Okay. But in control system subject and process control subject, you will see testing of second order models also, right? And this testing we will do in two domain, as I already discussed, one in time domain and another one in frequency domain. So in case of time domain, different excitations are applied, right? These three excitations are mentioned in our syllabus. We see the response of first order system uh, in with step input, with ramp input, and with impulse input. Hope it is clear to everybody.
Yes.
Yeah. Next, after that, the last thing under this dynamic characteristics of measurement system discussion is we see testing of first order system only. Okay, with only one excitation, that is sinusoidal input, but this happens in frequency domain. Already I told you what is this time domain and frequency domain. So hope you understand the things covered in today's class and then before that. So can I go to taking your attendance?
Yes, sir.
Yeah. Okay, answer your attendance.
1 to 5 present, sir.
1, 2, 3, 4, 5. See, one voice is coming and 5 attendance are coming. Can I see 5 different voices?
Sir, to avoid confusion, you can take line by line. It will be easy for you and us.
Yeah, yeah.
Line by line, if you go.
Okay, give attendance.
6 presents.
1 second.
Sir, you call the roll number, we will say present.
Okay, I will call them. Roll number 1. Roll number 2.
Present, sir. Roll number 1 left the meeting just before.
Okay, roll number 3.
Present, sir.
Roll number 4. What happened to roll number 4? Okay, roll number 5. Okay, roll number 6.
Present, sir.
Roll number 7. Roll number 8. Roll number 9. Roll number 10. Roll number 11. 12.
Yes, sir.
13.
Present, sir. Roll number 30.
Roll number 14. 15. 16.
Present, sir.
17.
Sir, roll number 10 present, sir.
Roll number 10 is present. Okay. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32.
32 present, sir.
33.